Right, let's have a look at this then. We've got area of a triangle here, half base times height. So if we're told, so the area is half, base times height. Oh, here we go, this problem here. Base is 6 and height is 4, so it's a half of 6 times 4, isn't it? So it'd be 3 fours are 12. 12 units squared. Here if we've got L and B, L is 5, B is 3, area equals L times B, suppose length times breadth I suppose. Then we can just put the numbers in, L is 5, B is 3, and we get 15 units squared. So R, let's put this one in here, is 4/3 pi R cubed when R is 1.6. So you can write that out as 4/3 pi R cubed, and the value of R is 1.6. So it'll be 4 divided by 3 times pi times R cubed. Oops. Times 1.6 cubed, wasn't it? There it is. 4/3 pi times R cubed. 17.16 to 2 dp. Okay, R is 2.3, H is 5.9, and pi R squared H, so it would be pi R squared times H, put it in a bracket if we want to, 2.3 squared, times H 5.9. So we tap that in the calculator, pi times 2.3 squared, wasn't it? Pi R squared times 5.9, pi R squared H, pi R squared H, 98.05 units, volume, so it's units cubed here, isn't it, for volume? Okay, L is 0.75, G is 9.81, so 2 pi, I'm just going to work out the number here, square root of L over G, so it's 2 times pi times the square root of L, 0.75, divided by 9.81 G. Okay, but that's all inside the square root, so don't need a bracket because it's done it for us on the calculator. We could use a bracket if we wanted, but it's not necessary. 1.74. Okay, good. Next one. E is, let's move down and get the next one. E, here we go. MGH, this times this, plus half MV squared. So let's do that one then. M, 0.2, times G, 9.81, times H, which is 20, plus, and instead of half, I'm going to write 0.5. It's easier to write like that. Times M, 0.2, times V, which is 4.6. So it's times 4.6 squared equals decimal 41.356. So it's 41.36. When we just write down the answer to save room, to 2 dp. Area equals length times breadth. Area, I'm rearranged for L, isn't it? So we can move the, so L is equal to then, and move the B from times on one side to divide on the other. A over B, that's how we do it. We move from times on one side to divide on the other. So that's a simple rule of algebra. So it's 100 over 20, so L will equal 5. So it has to be times on one side. So see the whole side in the sense of it's L, and we move it down to divide on the other side. So I hope you can see that's one of the rules for algebra. So when you have an equals, you can move it that way, from times to divide, or you can do the reverse. You can move from divide back up to times on the other side. So that's one rule of algebra, and you can picture it like that. But it has to be on one side, the whole side, not just part or a subpart of the side. So B is times the whole side here, L, and then it comes down and it divides under the a, which basically represents the whole side here, doesn't it? Okay, so bear that in mind then. Now, rearrange for x. Now we need to move the 3 across. So another picture is when you move it across the equals, something, an object through the equals, you have to flip the sign. That's the other rule of algebra. So if we move it this way, we flip the sign of the number. Be it positive, it becomes negative, or if it was negative, it becomes positive. And the same goes in the reverse. We flip the sign. So that's the next rule for algebra that we need. These two are usually what we need most times. So we'll move this across to the other side of the equals. Across, and we flip the sign. So y plus 3 equals 2x. Now when we've moved that over and we could write that, sometimes we don't bother writing it that way around, because if you have something equals something, then you can write it as the other way around, can't you? So move the 3 over, but I'm going to write it down from right to left. 2x then will equal the y plus 3, won't it? Because I want to rearrange for x. Now that's 2 times x. So I'm going to move the times now from times on one side to divide on the other side. So the y plus 3 is on the whole side. I move the 2 underneath. Now y is equal to oh, I've missed out one here. I've done the second one, haven't I? Y is equal to what? 1. Y is equal to 1. So x will equal 1 plus 3 over 2 is 4 over 2 is 2. So x is 2. Now go back to our previous... Oh, I've done the L one, haven't I, there? Good. Everything's okay then. Next one. So, y equals... So I'm going to scratch the 2 above now to give me some room. So I'm going to get rid of these 2 simple examples then, because we've just done them. And then we can do the next example. Move it up and just work on it. Okay, bear in mind these 2 rules. Let's have a look at this one then. And we'll scratch them as we go, I think. Okay, rearrange for x then. Move the 1 over. So y minus 1 is equal to 3 over x. Now I would have preferred to written that down the other way around. 3 over x equals y minus 1. So I'm going to do that straight away when I write it down. So the 3 over x then, which I'll put over here, is equal to the y minus 1, isn't it? Now, invert the fraction. So 1 over this, as long as you do the same thing to both sides. That's another thing you can do. So provided you do the same thing to both sides. So 1 over this number, 1 over 3 over x, is going to equal 1 over y minus 1. Okay? And then this comes up, the x will swing up to the top and you'll get x over 3 here. So you get x over 3. Okay, well that's one way to do it. You could flip the fraction upside down, but I'm just going to use our standard 2 rules. Let's see if we can do it with using the 2 rules. It might take slightly longer, but that's in a sense the fancy way to do it. But I'm just going to do it using moving divide to time. So I'm going to, this is an object on the side, isn't it? So let's move the x up there to times, see it? And then the y minus 1 can come down. Yeah? So move the x up. So I'm going to write it long-windedly, so I don't do too many steps in one fell swoop. And then I'm going to move the y minus 1 down. So the x there, that's as is, the 3 stays as is, and the y minus 1 moves some times to divide. There we go. So y is 4 then, so when y equals 4, x equals 3 over 4 minus 1. 3 over 3 is 1. So x is 1. Okay, next one then. So let's scratch that now. And we'll move on to the next one. So we want to rearrange this for h. And then we want to rearrange it for r. We've got the numbers here we'll put in a moment. Right, so rearrange for h. Well, leave the h as is here. And move the pi r squared underneath the other side. Pi r squared. See, it's times by this object times on this side. So I've just moved it from times on that side to divide on the other. So that will equal 78.2 over pi r squared. So it's 78.2 divided by, now it's a lot of stuff there, so I'm going to put a bracket, pi times r, 3.14. 3.14 squared. Close the bracket. 2.52 units. Okay, next one. Rearrange for r now, isn't it? The next part of the problem. So let's do that. So here, instead of... So let's scratch that now, because we've done that one. Now I'm going to do the second part. So rearrange for r. So here, see, you can think of this in your mind's eye as pi h times r squared, can't you? Because it's the same thing. So the pi h part of the product, I'm going to move that from times down to divide. So the r squared can stay as is. I'm going to write it down from right to left as well. So the r squared stays as is. The v can stay as is. And I'm moving the pi h from times on that side to divide on the other side. Here we go. Now to undo a square, you square root. Same on both sides, remember? You must do the same on both sides. So to undo a square, you have to square root. So if we square root both sides then, the square root of something squared is the object itself, and then we get the square root of the other side, v over pi h. So we can work out r. So it's the square root of v, 50, divided by, I'm putting a bracket, pi times h, 2.3. So it's pi times 2.3, close bracket, outside the square root, 2.63 to 2dp. Okay, good. Right, next one then. Okay, so we've done this bit here now. So let's get rid of this. And we'll work on this part of the problem now. Rearrange this formula for r. And find out r when v is 68.5. Okay, so the 4/3 pi, well I'm going to move the 3 because this is v equals 4 pi r cubed over 3. That's what it is. We have to write 4/3, but that's what this really is. So the 3 we can move up to be with the v, can't we? So move that up to times on the other side then. 3v equals 4 pi r cubed. Now move the 4 pi r cubed then. Badly written r there. Is equal to the 3v over 4 pi. To undo a cube, you cube root then. So let's cube root both sides. R will equal cube root of 3v over 4 pi. So tap it in the calculator then. The cube root is power third, so I'm going to use a bracket. 3 times v, 68.5. Okay, 3 times v divided by, I'll put a bracket again, 4 times pi. Close that bracket. Close the bracket for the whole thing, and it was that thing to the power third. 1 divided by 3. That's the cube root, it's power third. 2.53. Rounds up to 2dp is 2.54. Okay, now to undo a cube, you cube